In the year 3500 BC, a craftsman in Mesopotamia was searching for a new way to shape clay. Unknowingly, he created a simple, circular object that would forever change not only pottery but also commerce, warfare, and civilization itself. Fact 1. The potter's wheel was the wheel's quiet beginning. Before it carried chariots or carts, the wheel was a tool of artistry and creation. This first wheel, a heavy, spinning disc of stone or clay, allowed potters to form vessels with a symmetry and speed never before possible. For centuries, this was its primary purpose, a tool for making things, not for moving them. The idea of turning this horizontal spinner upright and placing it on an axle was a second, separate stroke of genius that came later. It was a slow evolution, a quiet thought passed from a craftsman's workshop to a cartwright's yard. But this simple circle, born from the need to shape the earth, would eventually set the world in motion. Fact 2. The simple nail predates the screw by millennia. Imagine the world before the nail. Structures were held together by complex, time-consuming joinery, interlocking pieces of wood, or bindings of rope and sinew. Then, more than 2,000 years ago, during the Roman Empire, a simple invention brought a new permanence to the world, a small, pointed piece of metal. Roman blacksmiths learned to cast and hammer bronze and iron into these slender fasteners. Suddenly, construction became faster, stronger, and more ambitious. With a humble nail, wooden beams could be joined with a few swift strikes, creating everything from humble homes to the formidable scaffolding of the Colosseum. It is a quiet, unassuming invention, yet it holds our world together, a silent testament to the power of a simple, strong connection. Fact 3. The first compass was a piece of floating stone. Long before complex gears and glowing screens, the earliest navigators relied on a strange and magical property of the earth itself. The first compasses, developed in Han Dynasty China around the 2nd century BC, were not used for sailing but for divination and orienting buildings. They were made from lodestone, a naturally magnetized piece of iron ore. When this stone was suspended so it could move freely, placed on a smooth surface or floated in a bowl of water, it would slowly, silently, align itself with the Earth's invisible magnetic field, one end always pointing south. It was a whisper from the planet itself, a secret direction revealed. Only centuries later was this mystical tool adapted for navigation at sea, freeing sailors from the need to hug the coastlines and allowing them to venture into the vast, open blue, guided by the quiet insistence of a floating stone. Fact 4. The printing press made knowledge blossom. Before the mid-15th century, a book was a rare and precious object, each letter painstakingly copied by hand, a process that could take months or even years. Knowledge was a treasure locked away in monasteries and royal courts. But Johannes Gutenberg's invention of the mechanical printing press changed the very nature of information. It wasn't just a single invention, but a combination of innovations: movable metal type, a press adapted from those used for making wine, and a new oil-based ink. Suddenly, ideas could be reproduced not just by the dozen, but by the thousand. Knowledge was freed. It began to spread like dandelion seeds on the wind, taking root in minds across continents. The quiet, solitary work of the scribe was replaced by the steady, rhythmic clatter of the press, a sound that heralded a new dawn of literacy and revolution. Fact 5. The telescope was born from a child's toy. The invention that would redraw our map of the universe began not in an astronomer's observatory, but likely in the workshop of a Dutch spectacle maker named Hans Lippershey in 1608. The story goes that two children playing in his shop placed two lenses in a line and were astonished to see that a distant weather vane appeared much closer. Lippershey refined this looker, but it was Galileo Galilei in Italy who, upon hearing of the device, built his own and did something revolutionary. He pointed it at the night sky. In the quiet of the night, through that simple tube of wood and glass, Galileo saw what no human had ever seen before. He saw mountains on the moons of Jupiter, and the countless individual stars that made up the misty river of the Milky Way. In an instant, our universe grew infinitely larger, and humanity's place within it became infinitely smaller and more wondrous. Fact 6. The steam engine harnessed the power of a cloud. The concept is as simple as the lid rattling on a boiling pot of water. For centuries, humans knew that steam, water transformed into a cloud of vapor, pushed and expanded. But it was in the 18th century that inventors like James Watt refined a way to capture this gentle, persistent force and put it to work. The steam engine doesn't work through an explosion. but through a calm, controlled process of expansion and condensation. Water is heated, its vapor gently pushes a piston, the vapor is cooled, and the cycle repeats. It is the steady breath of a machine. This rhythmic pulse of steam power quietly replaced the muscle of horses and the unpredictable power of wind and water. It gave humanity a tireless engine that could pump water from mines, power looms in factories, and pull trains across continents, changing the very rhythm of civilization itself. Fact 7. The telegraph turned electricity into a thought. For all of human history, the speed of a message was tied to the speed of a messenger. A letter could only travel as fast as the horse, the train, or the ship that carried it. That all changed in the 1830s and 40s with the invention of the electric telegraph. Samuel Morse and other pioneers found a way to send pulses of electricity down a long wire. By creating a code of short and long pulses, dots and dashes, they could translate the entire alphabet into a language of sparks. For the first time, a thought could travel across a continent in an instant, a whisper carried on a silent current. Imagine the quiet wonder of that first message, a staccato of clicks in a distant room spelling out words from miles away. The world suddenly felt smaller, connected by these thin, humming wires stretching over vast and silent landscapes. Very well. Let us continue our peaceful exploration. Settle back into that comfortable space, and let the story of human creativity gently carry you along. Fact 8. Photography first captured a ghost of light. Before the mid-1820s, the only way to preserve a scene was to paint it, a process filtered through the artist's hand and eye. But then, inventors like Nice 4 Niepce discovered a form of magic. They found that certain chemical compounds, like silver halides, would darken when touched by light. By coating a polished plate with these substances and placing it inside a dark box with a small opening, they could capture a ghostly impression of the world outside. The first photograph was a patient, silent process, requiring an exposure of many hours. Light itself was the artist, slowly, meticulously painting an image onto the plate. For the first time, a moment in time could be frozen, a fleeting pattern of light and shadow given permanence, allowing us to gaze upon the real face of a long-vanished past. Fact 9. The light bulb created a personal, captured star. For all of history, the night was a vast and powerful wilderness, held at bay only by the flickering, unsteady light of fire. Candles, oil lamps, and gaslights offered a warm but living light that danced and smoked. The dream was to create a clean, steady, and safe illumination, a tiny, captured sun for every room. Thomas Edison's great achievement was not in inventing the idea, but in finding the perfect, humble material to make it last. His team tested thousands of filaments, searching for a simple thread that could glow brightly without burning out. The answer came in a sliver of carbonized bamboo. When sealed inside a glass vacuum and touched with a current, it produced a steady, peaceful, and enduring glow. It was a fire without flame, a light without smoke, a small, quiet miracle that tamed the darkness and reshaped the rhythm of our daily lives. Fact 10. The telephone sent a whisper of a voice down a wire. The telegraph had already conquered distance with coded clicks, but the telephone achieved something far more intimate. In 1876, Alexander Graham Bell spoke a simple instruction to his assistant in another room. "Mr. Watson, come here. I want to see you." Those words were transformed into a fluctuating electrical current, a vibrating ghost of his voice that traveled through a wire and was reborn as sound on the other end. It was the capture and transmission of a human voice itself, with all its tone, emotion, and nuance. The invention allowed a mother to hear her child's laughter from across a city, a business to be conducted with the clarity of conversation, and the world to be bound not just by information, but by the very sound of the human voice, a miracle of connection carried through silent metal. Fact 11. Refrigeration created a personal winter. Throughout history, humanity's diet was governed by the seasons and the relentless march of decay. Food had to be eaten quickly, or preserved through the ancient methods of salting, smoking, or drying. But in the late 19th and early 20th centuries, the invention of mechanical refrigeration brought a profound change to every kitchen. It created a small, cold, and quiet space that could defy the seasons. By using a cycle of compressing and expanding gas, a refrigerator gently pumps heat out of an insulated box, creating a perpetual state of artificial winter inside. This silent, humming machine slowed down the work of bacteria, preserving food for days or weeks. It allowed for the transportation of fresh milk, meat, and vegetables over vast distances, fundamentally changing our relationship with food and freeing our diets from the tyranny of the calendar. Fact 12. The airplane was born from watching birds. The dream of flight is as old as humanity itself. We watched birds soar on invisible currents and longed to join them. For centuries, our attempts were clumsy and focused on mimicking the flapping of wings. But two brothers, Wilbur and Orville Wright, approached the problem with a quiet, meticulous patience. They were not just inventors, they were observers. They studied how birds angled their wings to turn and maintain balance, and they developed a system called wing warping to imitate it. Their first successful airplane was not a powerful beast, but a delicate construction of spruce, ash, and muslin. And its first flight, on a cold December day in 1903, was not a mighty roar into the heavens. It was a fragile, 12-second hop, a powered glide that lifted a human off the earth for a mere 120 feet. But in that brief, quiet moment, humanity had finally, gently, touched the sky. Fact 13. Penicillin was a discovery of quiet observation. In 1928, the scientist Alexander Fleming returned from a holiday to a cluttered laboratory. He was sorting through old petri dishes containing bacteria when he noticed something odd. On one dish, a patch of mold was growing, and around that mold was a clear, empty circle, a zone of silence where the bacteria could not survive. He realized, with a flash of insight, that the mold was producing a substance that was a silent killer of bacteria. He called this substance penicillin. It was a secret weapon produced by a humble fungus, a discovery born not from a grand experiment, but from a moment of quiet, curious observation of an accident. This mold juice would become the world's first true antibiotic, a gentle but powerful tool that could fight deadly infections from within, saving countless millions of lives and changing the course of medicine forever. Fact 14. The transistor taught a crystal how to think. The first computers were enormous, power-hungry machines filled with thousands of fragile, glowing vacuum tubes that acted as switches. Then, in 1947, 3 scientists at Bell Labs invented something that would change everything: the transistor. It was a tiny, solid piece of semiconductor material, like silicon, with no moving parts, no vacuum, and no filament to burn out. By applying a tiny electrical charge, this small crystal could be taught to either block a larger current or let it pass, acting as a perfect, silent, and instantaneous switch. This simple, revolutionary device could be made microscopically small. Today, billions of these silent switches are etched onto a single microchip, forming the brain of every smartphone, computer, and modern electronic device. All of our digital world is built upon this simple principle, teaching a sliver of crystal how to say yes or no. Fact 15. The aqueduct taught water how to walk. The great cities of the Roman Empire were marvels of engineering, but they could not have existed without a constant, life-giving supply of fresh water. The aqueduct was the solution, and its genius was its profound simplicity. It was not a pump or a machine, but a quiet collaboration with gravity. Roman engineers surveyed the land with meticulous patience, designing channels that sloped ever so slightly, a gentle, barely perceptible decline over dozens of miles. These channels, carried atop those iconic stone arches, were like artificial rivers, coaxing water to flow gracefully from a distant mountain spring all the way to the fountains and baths of the city. It was a silent, steady, and unending stream, a testament to the power of understanding the quiet, persistent pull of the earth. Fact 16. The plow opened a conversation with the soil. For early farmers, planting was a battle with the surface of the earth. They could only scratch at the soil with sticks or hoes. The invention of the plow, first a simple wedge of wood pulled by an ox, transformed this relationship. But it was the later invention of the iron moldboard plow that began a true revolution. This heavier, curved plow did not just break the soil. It gently lifted and turned it over in a long, continuous ribbon. This quiet act of turning the earth buried weeds and stubble, bringing fresh, nutrient-rich soil to the surface. It was a simple, rhythmic motion that allowed farming to move beyond subsistence, creating the agricultural surpluses that fed the first towns and cities, all born from a simple tool that deepened our conversation with the land. Fact 17. Barbed wire drew quiet lines across the land. The vast open plains of the American West were once a boundless ocean of grass, a territory defined by horizons, not fences. This changed in 1874 with a simple but transformative invention. Joseph Glidden's design for barbed wire was a machine that could twist two strands of wire together, locking sharp barbs into place. It was a line of thorns made of steel, and it was remarkably effective. Unlike a wooden or stone fence, it required very little material and could be strung up quickly over immense distances. With this quiet and methodical invention, the open range was enclosed, and vast territories were divided into individual parcels of land. It was a simple, twisted wire, but it silently and permanently redrew the map of the continent. Fact 18. The cotton gin unburdened a delicate fiber. Before 1794, processing cotton was a slow and painstaking task. Each soft ball of cotton was filled with small, sticky green seeds that had to be picked out by hand. It could take a person an entire day to clean a single pound of fiber. Eli Whitney's invention, the cotton gin, was a simple mechanical solution. It used a rotating drum with wire teeth or hooks that would pull the cotton fibers through a mesh screen that was too fine for the seeds to pass through. It was a mechanical comb, gently and rapidly teasing the seeds away. A single, small, hand-cranked gin could do the work of 50 people, and this quiet increase in efficiency transformed economies, making cotton a profitable global commodity and profoundly, and often tragically, reshaping the societies that grew it. Fact 19. The rocket pushed against nothing to reach the stars. The principle behind a rocket is one of the purest laws of physics. For every action, there is an equal and opposite reaction. A rocket does not push against the air or the ground. It pushes against itself. By throwing a huge amount of gas out of its back at incredible speed, the universe, in turn, pushes the rocket forward. The first person to truly understand this and bring it to life was Robert Goddard. In the quiet fields of Massachusetts in 1926, he launched the world's first liquid-fueled rocket. It was a small, spindly device that flew for only 2.5 seconds, reaching a height of 41 feet. It was a silent, almost comical leap compared to the thundering launches of today. But in that small, graceful arc, a new age had begun, one that would eventually, quietly, push humanity all the way to the moon. Fact 20. The battery was a quiet, captured lightning. Electricity was once a fleeting and wild phenomenon, a spark from static or a bolt from the sky. It could not be stored. That was until 1800, when Alessandro Volta created the first true battery. He discovered that stacking discs of two different metals, like zinc and copper, and separating them with brine-soaked cloth, would produce a steady, silent, and continuous electrical current. His voltaic pile was a simple tower of metals, a layer cake that chemically coerced electrons to flow. For the first time, humanity had a portable and reliable source of electricity. It was a quiet, contained wellspring of power that could be used for experiments anywhere, anytime, freeing the study of electricity from the lightning storm and the friction machine, and paving the way for the electronic world to come. Fact 21. The thermos created a fortress of nothingness. How do you keep a hot drink hot or a cold drink cold? The elegant solution, invented by James Dewar in 1892, was not to add something, but to take something away. The genius of the vacuum flask, or thermos, is the empty space between its two walls. Air is a poor conductor of heat, but a vacuum, a space with almost no air at all, is a truly excellent insulator. Heat struggles to travel through this pocket of nothingness. This simple, clever design creates a quiet, invisible barrier, a fortress that slows the transfer of thermal energy to a crawl. It's a marvel of passive engineering, a way to preserve a small island of temperature, using the profound and simple power of empty space. Fact 22. The radio learned to hear the invisible. For millennia, we believed the air around us was empty and silent. But in the late 19th century, scientists like Heinrich Hertz and Nikola Tesla discovered that it was filled with invisible waves, a spectrum of electromagnetic energy. It was Guglielmo Marconi who, in 1901, had the audacious idea to use these waves to send a message across the Atlantic Ocean. From a station in England, his team transmitted the simple Morse code signal for the letter S, 3 faint dots. Across 2,000 miles of storm-tossed ocean, in Newfoundland, Marconi pressed a receiver to his ear and heard it. A tiny, rhythmic clicking, a whisper caught from the empty air. It was a sound that had traveled through the ether, unbound by wires, proving that voices, music, and ideas could be cast into the air itself, ready to be caught by anyone with the patience to listen. Fact 23. The barometer listened to the weight of the sky. Weather was once a divine mystery, a whim of the gods. But in 1643, Evangelista Torricelli, a student of Galileo, performed a quiet and elegant experiment. He filled a long glass tube with mercury, sealed one end, and inverted it into a dish. He noticed that the column of mercury in the tube did not empty completely. It remained suspended at a certain height. He correctly reasoned that the invisible weight of the atmosphere, the vast ocean of air above us, was pressing down on the mercury in the dish and holding the column up. He had created the first barometer. The slow, silent rise and fall of that silver liquid was the atmosphere whispering its secrets, revealing its changing pressure. For the first time, humanity had a tool to foresee the coming of storms or calm, not through superstition, but by listening to the quiet weight of the air. Fact 24. The elevator's brake gave us permission to build the sky. For centuries, the height of our buildings was limited not by engineering, but by the endurance of our legs. A building was only as tall as a person was willing to climb. The elevator existed in a crude form, but it was considered dangerously unreliable. Then, in 1854, Alicia Otis demonstrated an invention that was not about lifting, but about failing safely. On a demonstration platform high in the air, he ordered the rope to be cut. The crowd gasped, but the platform dropped only a few inches before a simple, spring-loaded safety brake engaged, locking it in place. It was this quiet guarantee of safety, this promise of a gentle stop, that truly allowed our cities to grow upwards. Architects were now free to dream of skyscrapers, knowing that a simple, reliable machine could safely carry us into the clouds. Fact 25. The lock and key created a secret made of metal. The idea of securing a personal space is ancient. The first locks, developed by the Egyptians 4,000 years ago, were large wooden devices. But it was the Romans who perfected the small, portable metal lock and key. The principle is one of quiet ingenuity. A series of small pins or tumblers inside the lock must be lifted to a precise height, all at the same time, to allow the bolt to move. The key is the one unique object whose jagged edge is a perfect map of those heights. It is a small, intricate puzzle. The lock does not require immense strength. It requires the correct secret. This humble invention allowed for the concept of personal privacy and property to flourish, creating a small, secure, and silent world that could be carried in one's pocket. Fact 26. The mechanical clock gave time a steady heartbeat. Before the 14th century, time was a fluid and natural thing, measured by the slow swing of a shadow on a sundial or the gentle drain of a water clock. But the invention of the mechanical clock, with its revolutionary escapement mechanism, changed our relationship with time forever. The escapement is a device that translates the steady energy of a falling weight into a rhythmic, controlled motion, a gentle tick and a slow tark. It breaks the continuous flow of energy into small, equal, and audible pieces. This quiet, steady beat gave civilization a new pulse. It allowed for the synchronization of life, for scheduled appointments, for coordinated work. The sun no longer dictated the hour, the steady, peaceful heartbeat of the clock did. Fact 27. The sewing machine taught two threads how to dance. For all of history, creating clothing was an incredibly slow process, each seam formed by a single thread pushed and pulled by hand. Many had tried to invent a machine to replicate this, but the true breakthrough came from solving a simple problem: how to create a strong stitch with a needle that only passed through the fabric once. The elegant answer was the lock stitch, perfected by inventors like Elias Howe. It used two separate threads, one from the needle above and one from a small bobbin, called a shuttle, below. In a quiet, intricate dance, the needle would dip down, create a small loop, and the shuttle would pass through that loop, locking the two threads together in the heart of the fabric. This simple, strong, and beautiful stitch created a quiet hum that replaced centuries of silent manual labor. Fact 28. Concrete was Rome's forgotten liquid stone. When we think of Roman ruins, we imagine carved marble and stacked bricks. But the secret to their most magnificent and enduring structures, like the vast, unsupported dome of the Pantheon, was their mastery of concrete. Roman concrete was a simple but brilliant recipe of volcanic ash, lime, water, and small stones. When mixed, it created a thick, heavy liquid that could be poured into molds of any shape. But then, a slow, quiet chemical reaction would begin, and this liquid stone would harden into a single, seamless, and incredibly strong mass. It was a material that was both versatile and immensely durable. After the fall of Rome, the recipe for this magnificent material was lost for over 1,000 years, leaving their silent, colossal structures as a mystery to the architects who followed. Fact 29. The vaccine taught our bodies how to remember. For all of history, diseases like smallpox were terrifying, unstoppable forces of nature. The only defense was to survive an infection. But in the late 18th century, a country doctor named Edward Jenner made a quiet and profound observation. He noticed that milkmaids who had contracted cowpox, a mild disease from cows, seemed to be protected from the deadly scourge of smallpox. He theorized that he could teach a person's body to fight the greater disease by first introducing it to the lesser one. In a gentle, careful procedure, he introduced material from a cowpox sore to a young boy. The boy developed a mild fever and then recovered. Later, when exposed to smallpox, he remained perfectly healthy. It was the world's first vaccine, a whispered warning to the immune system, allowing it to build its defenses silently and without a fight, preparing the body for a battle that would now never have to be fought. Fact 30. The canning of food created a world without time in a jar. Before the 19th century, armies and sailors were plagued by a lack of fresh food on long journeys. In response to a challenge from Napoleon Bonaparte, a French confectioner named Nicolas Appert began a series of simple experiments. He discovered that if he gently heated food in a thick, sealed glass jar and then allowed it to cool, it would remain preserved for months. He did not know about the existence of germs. He only knew that his quiet process worked. By heating the food, he was unknowingly killing the microscopic organisms that cause decay, and by sealing the jar, he was preventing any new ones from entering. This simple act of creating a silent, sterile world inside a bottle transformed the logistics of the entire world, allowing explorers and armies to carry the bounty of a summer harvest with them through the dead of winter. Fact 31. The friction match put a star in our pocket. Creating fire was once a skill, a laborious process of striking flint against steel or spinning a wooden drill until a spark was born. The invention of the first friction match in the 1820s changed this forever. Early matches were a combination of chemicals on the tip of a small wooden stick that, when struck against a rough surface, would burst into flame. It was a tiny, controlled, and instantaneous chemical reaction, a sleeping volcano that could be awakened with a single, quiet scrape. This simple invention democratized fire, making it accessible, portable, and reliable. The immense power of combustion, the energy of a small star, was now tamed, held dormant on the tip of a sliver of wood, ready to bring warmth and light to anyone, anywhere. Fact 32. Dynamite taught an explosion how to be patient. The chemical nitroglycerine, discovered in the mid-19th century, was an incredibly powerful explosive, but it was also dangerously unstable, prone to exploding from a simple jolt. Alfred Nobel's great quest was to tame this power. He experimented tirelessly, searching for a way to make the volatile liquid safe to handle. He found his solution in a porous, absorbent earth called kieselguhr. When he mixed the liquid nitroglycerine into this fine powder, it became a stable, dough-like substance. This was dynamite. Its genius was not in its power, but in its patience. It would remain perfectly silent and inert until it was deliberately awakened by a blasting cap. Nobel had turned a chaotic and unpredictable force into a precise and reliable tool, an explosion that would wait for a command. Fact 33. The zipper is a quiet and elegant handshake. For centuries, garments were fastened with a series of individual and often frustrating buttons, hooks, or laces. The zipper, perfected in the early 20th century, replaced this fiddly work with a single, fluid motion. Its beauty is in its simple, mechanical elegance. It consists of 2 rows of interlocking teeth. The slider, when pulled, contains a simple Y-shaped channel that gently angles the teeth together, persuading them to link like a seamless handshake. When pulled the other way, a small wedge inside the slider gently pries them apart. It is a quiet, satisfying, and efficient piece of engineering. 2 simple lines that, with a single gesture, can be coaxed into becoming one. Fact 34. The ATM created a silent conversation about money. Our access to our own money was once limited by the walls of a bank and the hours of a business day. The invention of the automated teller machine, or ATM, in the 1960s, changed this relationship. The first machines were simple dispensers, but they represented a profound shift, a trusted mechanical servant that could perform a financial transaction. The simple, quiet process of inserting a plastic card and entering a secret code was a new kind of conversation, one held between a person and a machine. It created a new autonomy, freeing people from the need to plan their lives around the bank's schedule. This quiet, solitary transaction, available day or night, was a small but significant step in the ever-evolving story of our relationship with currency. Fact 35. The Internet began as a quiet whisper between machines. The vast, noisy, and all-encompassing network we know today began as a quiet and careful government experiment in the late 1960s called ARPANET. The goal was not to connect the world, but to solve a simple problem. How could a few key university computers continue to share information even if some parts of the network were destroyed or failed? The solution was a decentralized network, a web with no center, where information could be broken into small packets and cleverly routed around any damage. The first message sent on this network was simply the word login. The system crashed after the first two letters, LO. But in that quiet, failed attempt, the first threads of a global web had been woven, a resilient, silent network that was destined to grow and connect all of humanity. Fact 36. The sextant allowed us to navigate by the stars. For ancient mariners, the open ocean was a place of profound uncertainty. Once land disappeared over the horizon, they were lost in a vast and featureless world. The sextant, a beautiful instrument of brass and mirrors perfected in the 18th century, brought certainty to this wilderness. It is a tool of quiet, celestial geometry. By looking through its eyepiece, a navigator could simultaneously see the horizon and, through a clever system of mirrors, bring the sun or a star down to meet it. By measuring the precise angle between the two, they could determine their latitude, their exact distance from the equator. It was a quiet, daily ritual, a silent conversation between a lone sailor and the predictable, clockwork heavens that finally unlocked the secrets of global navigation. Fact 37. The microphone gave a giant's voice to a whisper. Our voice is a gentle thing, a vibration of air that fades quickly with distance. The invention of the microphone in the late 19th century was the discovery of how to give that whisper an infinite reach. The principle is simple and delicate. The subtle pressure of sound waves causes a thin diaphragm to vibrate, just as our eardrum does. This tiny, almost imperceptible movement is then translated into a corresponding electrical signal. This electrical ghost of the sound can then be amplified, recorded, or broadcast. For the first time, a single, soft-spoken person could fill a vast auditorium. A quiet song could be heard by millions, and the most intimate of sounds could be preserved forever, all thanks to a device that learned how to listen. Fact 38. The hypodermic needle created a quiet path into the body. Before the mid-19th century, medicine was largely an external affair. Potions were swallowed, and salves were applied to the skin. The hypodermic needle and syringe provided a new, direct, and incredibly precise path. It was the simple combination of a hollow, sharpened needle and a plunger that could push liquid through it. This allowed for a small, measured dose of medicine to be delivered silently beneath the skin, directly into the bloodstream or muscle. This quiet and targeted delivery revolutionized medicine, making it possible to administer pain relief, life-saving vaccines, and countless other treatments with a new level of speed and effectiveness, all through a tiny, silent gateway. Fact 39. The laser is light that has been taught to be disciplined. The light from a candle or a light bulb is a chaotic thing, a jumble of different wavelengths all moving out of sync, like a disorganized crowd. A laser is different. It is light that has been brought into perfect, harmonious order. Inside a laser, a process of stimulated emission coaxes photons to align, to travel in the same direction, and to vibrate at the exact same frequency. The result is a pure, single-colored, and perfectly straight beam of light. It is a quiet, disciplined column of energy. This silent, orderly beam is now used in thousands of applications, from the gentle red light that reads a barcode to the precise tool that a surgeon uses to perform delicate operations, all because we learned how to teach light how to be calm. Fact 40. GPS is a conversation with a man-made constellation. Today, we can know our precise location on the planet at any moment, but this miracle depends on a silent, continuous conversation happening high above our heads. The global positioning system is a network of satellites, a man-made constellation, each one orbiting the Earth in a predictable path. And each satellite does one simple thing: It constantly broadcasts a quiet signal that says, "I am here, and the time is now." Down on the ground, your phone or GPS device listens for these faint whispers. By catching the signals from at least 4 different satellites, and by measuring the tiny, fractional differences in the time it took each signal to arrive, the device can perform a quiet calculation to triangulate its own exact position. It is a constant, global, and silent ballet that tells us exactly where we are. Fact 41. The air conditioner created a personal springtime. For most of history, entire regions of the world were rendered nearly uninhabitable or unproductive during the sweltering heat of summer. The invention of modern air conditioning in the early 20th century tamed the seasons themselves. Like a refrigerator, it doesn't create cold, it simply moves heat. A chemical refrigerant flows through indoor coils, and as it evaporates, it silently absorbs heat and moisture from the air, like a mechanical sponge. This heat is then carried outside and released. This quiet, continuous cycle creates a personal, artificial springtime, an indoor climate of cool, dry air, no matter how hot it is outside. This simple invention changed where people could comfortably live and work, leading to the explosive growth of cities in the hottest parts of the world. Fact 42. The barcode gave machines a language to read. Look closely at almost any product, and you will see a small patch of black and white stripes. This humble barcode is a masterpiece of simple, efficient design. It is a quiet, written language intended not for us, but for machines. Each number from 0 to 9 is represented by a unique pattern of lines and spaces. A laser scanner in a checkout lane or a warehouse sweeps a gentle beam of red light across this pattern. The light is absorbed by the black lines and reflected by the white spaces, creating a unique electrical signal that the computer instantly recognizes. This silent, instantaneous conversation replaced the slow, error-prone process of typing in prices by hand, creating the quiet efficiency that powers all of modern commerce. Fact 43. The windshield wiper brought clarity to a storm. In the early days of the automobile, driving in the rain or snow was a nearly impossible task. A driver would have to constantly stop the car to wipe the windscreen by hand, or bravely lean out of the side to see the road ahead. In 1903, a woman named Mary Anderson observed this struggle and sketched a simple, elegant solution. It was a rubber blade attached to an arm that could be operated by a lever from inside the car. This was the first effective windshield wiper. It was a simple, rhythmic, and mechanical hand that could sweep the rain away, over and over, in a quiet and steady dance. This humble invention brought a new safety and persistence to driving, allowing us to see clearly, even when the world outside is a blur. Fact 44. The dam taught a river how to be still. A river is a powerful and wild thing, a force of constant movement. The great dams of the world are a testament to our ability to negotiate with this power. A dam is more than just a wall. It is a carefully engineered structure that persuades a river to pause its journey. The weight of the water, pressing against the vast, curved face of the dam, is held in a state of quiet, immense tension. Behind this barrier, the wild river calms, transforming into a deep, still, and predictable lake. This quiet act of holding back water has irrigated deserts, prevented catastrophic floods, and, with the addition of turbines, has used the patient power of the falling water to generate clean, silent electricity for millions. Fact 45. Pasteurization was a gentle negotiation with germs. In the 19th century, Louis Pasteur was asked to solve a simple problem. Why did wine and beer so often spoil? He discovered that the culprits were microscopic organisms, but he also found that he didn't need to boil the liquid to save it, which would ruin the taste. Instead, a brief and gentle heating to a specific temperature was enough to kill the harmful microbes while leaving the flavor largely untouched. This process, pasteurization, was a quiet, precise, and gentle intervention. It was not a war on all germs, but a targeted negotiation with the invisible world, a way to make our food safer and last longer through a carefully measured application of warmth. Fact 46. The traffic light created a silent, universal language. The first city intersections were places of noisy, chaotic, and dangerous confusion. As cars, carts, and pedestrians all tried to cross at once, the only law was the loudest horn or the bravest step. The first electric traffic lights, installed in the 1910s, brought a new and quiet order to this chaos. The simple, rhythmic cycle of glowing colors, red for stop, green for go, created a universal language that everyone could understand instantly. It was a set of silent, glowing commands that organized the flow of a city into a predictable and coordinated dance, a quiet pulse that allows millions of people to move through the same spaces safely and in harmony. Fact 47. The ballpoint pen made the written word flow. For centuries, writing was a tethered act, tied to an inkwell. The fountain pen was an improvement, but it was prone to leaking and smudging. The genius of the ballpoint pen, patented by Laszlo Biro in 1938, was its beautiful simplicity. At its very tip is a tiny, free-rotating metal ball, usually less than a millimeter wide, held perfectly in a small socket. This tiny sphere acts as a cap, sealing the ink inside. But when the pen is moved across paper, the ball rolls, picking up a thin, even layer of thick, quick-drying ink from the cartridge and rolling it onto the page in a continuous, quiet ribbon of color. It is a simple, reliable mechanism that finally made writing an effortless, clean, and truly portable act. Fact 48. The safety razor tamed a dangerous blade. For millennia, shaving was a task that required skill, a steady hand, and a very sharp, open blade. The straight razor was effective, but it was also unforgiving and dangerous. In the late 19th century, King C. Gillette had a simple but revolutionary idea. What if the blade could be disposable, and what if it could be held in a device that made it safe? The result was the safety razor. It was a simple holder that gently caged a thin, sharp piece of steel, exposing only the very edge of the blade at a precise, forgiving angle. This quiet innovation removed the fear from a daily ritual, turning a task that required the skill of a barber into a simple, safe routine that anyone could perform. Fact 49. Velcro was a quiet secret borrowed from a weed. After a hunting trip in the Alps in 1941, Swiss engineer George de Mestral noticed the stubborn burrs that clung to his coat and his dog's fur. Instead of just brushing them off, he looked at one under a microscope. He saw a simple, ingenious design, hundreds of tiny, flexible hooks that would catch on anything with a loop, like the fibers of his clothing. He spent the next decade creating a man-made version of this quiet, natural fastener. The result was Velcro, a name derived from the French words for velvet and hook. It is two simple strips of nylon, one a field of tiny hooks, the other a meadow of soft loops. The quiet ripping sound it makes is the collective release of thousands of these simple, persistent connections, a clever idea borrowed from a silent walk in the woods. Let us continue our gentle drift. With each fact, allow yourself to sink a little deeper into comfort, letting the stories of these quiet creations be a soft blanket for your mind. Fact 50. The abacus gave numbers a physical home. Before written numerals were common, how did one calculate the trade of a large caravan or the design of a great temple? The answer, for thousands of years, was the abacus. It is a disarmingly simple tool, a quiet, tactile calculator made of a wooden frame and beads sliding on rods. But in this simplicity lies its genius. The abacus gives abstract numbers a physical form that you can see and touch. Each bead, each rod, represents a value, allowing complex calculations like addition, subtraction, multiplication, and even square roots to be performed with a series of quiet, rhythmic clicks. It was a silent partner to merchants and engineers across the ancient world, a way to hold a thought in your hands. Fact 51. Paper was created from the ghosts of plants. For centuries, the written word was a heavy thing, carved into stone or pressed into clay. Lighter surfaces, like papyrus or parchment, were expensive and labor-intensive. The invention of paper in China, around the 2nd century AD, was a miracle of humble things. It was a recipe that took the fibrous essence of plants, mulberry bark, hemp, and old rags, and transformed it. These materials were mashed into a wet pulp, pressed into thin, delicate sheets, and left to dry in the sun. The result was a surface that was wonderfully lightweight, absorbent, and cheap to produce. It was a quiet revolution that untethered knowledge from its heavy foundations, allowing ideas to travel as easily and as lightly as a folded letter. Fact 52. The submarine learned how to breathe water. To explore the world beneath the waves, a vessel must master a simple, quiet trick. It must learn how to change its own weight. The secret to the submarine is the ballast tank. To dive, large vents are opened, and the submarine takes a deep breath of seawater, filling its tanks. This added weight makes it heavier than the water around it, and it begins a slow, silent descent into the quiet dark. To rise, Compressed air is blown into the tanks, forcefully pushing the water out. Now lighter, the vessel gently ascends back to the world of light and air. This simple, controlled breathing is what allows a submarine to navigate the vertical geography of the ocean, a quiet marvel of buoyancy. Fact 53. The thermometer gave a number to warmth. For all of history, heat and cold were just feelings, subjective and impossible to measure precisely. Was this fever worse than yesterday's? Is this water warm enough? The first thermometers, developed in the 17th and 18th centuries, brought a quiet certainty to this invisible world. By sealing a liquid like alcohol or mercury in a narrow glass tube, inventors noticed that the liquid would silently and predictably expand when warm and contract when cold. By adding a scale of measured marks alongside this moving column, they gave a number to warmth. This simple tool transformed science, medicine, and even cooking, allowing us to understand and control the silent, thermal dance of molecules all around us. Fact 54. The bicycle is an act of falling and catching yourself. The design of the modern bicycle is one of elegant, paradoxical beauty. It is an object that is inherently unstable. At rest, its two thin wheels in a line offer no support. But the moment it moves forward, it becomes a model of grace and efficiency. Riding a bicycle is a continuous, quiet act of falling and catching yourself. Every tiny turn of the handlebars is a correction, a subtle shift in balance that keeps the machine upright. It is a perfect, silent partnership between human and invention, a tool that amplifies the gentle rhythm of our own bodies into effortless, gliding speed, the most efficient form of self-powered transport ever created. Fact 55. The stapler performs a simple, metal stitch. For centuries, loose pages were a nuisance, held together by straight pins that pricked fingers, ribbons that came undone, or messy wax seals. The invention of the stapler brought a quick, clean, and lasting order to our paper world. With a single, satisfying click, it performs a perfect, simple stitch. A mechanism inside the stapler pushes a small, pre-formed metal staple through a stack of papers. As it emerges on the other side, its two legs are met by a small, grooved plate called an anvil, which quietly and neatly folds them inward, locking the pages together. It is a small, quiet act of unity, a humble machine that brings a calm and lasting order to our thoughts. Fact 56. Anesthesia was the discovery of a quiet sleep. Before the mid-1840s, surgery was a brutal race against time and pain. It was a terrifying, conscious ordeal for the patient. The discovery of modern anesthesia was the discovery of a way to press a gentle pause button on consciousness itself. Substances like ether and chloroform, when inhaled, could induce a deep, temporary, and painless sleep. This profound invention gave surgeons the one thing they had never had: time. No longer forced to rush, they could now work slowly, carefully, and with a new level of precision. Anesthesia transformed surgery from an act of frantic, desperate butchery into a delicate and life-saving art, all made possible by the quiet miracle of a borrowed sleep. Fact 57. The sewing needle was humanity's first tool for tailored warmth. Long before the sewing machine, our ancestors survived the cold with a simple, slender piece of sharpened bone or ivory. The true stroke of genius in this quiet tool was the eye, a tiny, drilled hole at one end. This small opening allowed a thread of sinew or plant fiber to be passed through, transforming a simple piercing tool into a sophisticated device for stitching. With this humble needle, animal hides could be carefully joined together, creating the first fitted clothing that trapped body heat and allowed our species to endure the bitter cold of the ice ages. It was a quiet, meticulous invention that brought us a new intimacy with warmth. Fact 58. The QWERTY keyboard was designed to be deliberately slow. The layout of the keys on our keyboards is a quiet echo from a mechanical past. When the first typewriters were invented, typists became so fast that the machine's metal arms, each holding a letter, would collide and jam. The inventor, Christopher Sholes, solved this problem by creating the QWERTY layout. He carefully placed the most commonly used letters far apart, forcing the typist to slow down just enough to allow the mechanical arms to fall back into place. This quiet, clever solution, designed for inefficiency, has now become the unquestioned standard, a silent pattern that guides our fingers in a digital world. Fact 59. The can opener was invented 50 years after the can. For half a century, the miracle of canned food came with a difficult challenge: opening the can itself. The first cans were thick, heavy containers of wrought iron, and the instructions were often simply, cut round the top near the outer edge with a chisel and hammer. Getting inside was a noisy and difficult task. The invention of the simple, lever-based can opener in the 1850s was a quiet revolution. With a simple, rotating cutting wheel, it allowed anyone to open a can easily and safely, finally unlocking the full potential of this preserved food and making it a staple of kitchens around the world. Fact 60. The stethoscope was invented out of modesty. In 1816, the French physician René Laennec was uncomfortable with the common practice of placing his ear directly on a female patient's chest to listen to her heart. Seeking a more modest alternative, he recalled seeing children playing with a long piece of wood, scratching one end and listening to the amplified sound at the other. He rolled a tube of paper, placed one end on his patient's chest and the other to his ear, and was astonished by the clarity of the sounds he heard. This simple tube was the first stethoscope, a quiet invention that amplified the internal symphony of the body, the gentle rush of air in the lungs and the steady, rhythmic beat of the heart, giving doctors a powerful new window into our inner world. Fact 61. Glass is a liquid that has been taught to stand still. The creation of glass is a quiet and ancient magic. It begins with simple sand, which is heated in the intense, silent heat of a furnace until it surrenders its solid form and melts into a glowing, honey-like liquid. This molten sand, while still in its fluid state, can be poured, blown, and shaped. But as it cools, it does something remarkable. It becomes rigid and transparent without ever forming the ordered, crystalline structure of a true solid. It is an amorphous solid, a liquid that has been caught in a moment of stillness. This simple, beautiful material gave us quiet windows to let in light without the cold, and clear vessels to see the contents within. Fact 62. The post-it note was born from a failed glue. In 1968, a scientist at 3M named Spencer Silver was trying to invent a super-strong adhesive. Instead, he accidentally created the opposite, a very weak glue that was just tacky enough to stick to things, but could be easily peeled off without leaving a mark. It was a solution without a problem, a quiet failure. 4 years, nothing came of it, until a colleague, Art Fry, grew frustrated with the paper bookmarks falling out of his church hymn book. He remembered the weak glue, coated some small squares of paper with it, and the post-it note was born. It was the perfect temporary bookmark, a way to leave a quiet note that was a gentle, non-committal promise. Fact 63. The microwave oven cooks with a silent, invisible hum. The discovery that launched a kitchen revolution happened quietly and by accident. In 1945, an engineer named Percy Spencer was working with a magnetron, a device that generates microwaves for radar systems, when he noticed that a chocolate bar in his pocket had melted. He realized that these invisible waves could heat food. The microwave oven works by emitting these waves, which cause the water molecules within the food to vibrate back and forth with incredible speed. This vibration creates friction, and this friction creates heat, cooking the food from the inside out. It is a quiet, invisible process that turned the slow art of cooking into a fast and simple science. Fact 64. The assembly line was a river of quiet repetition. Before the early 20th century, a product like a car was built by skilled craftsmen who would move around the workshop, slowly assembling it piece by piece. Henry Ford's innovation was to reverse this. He created a moving assembly line that brought the work to the worker. Each person stood still, performing just one or two simple, repetitive tasks over and over, as the product glided silently past them. It was a way of deconstructing a complex task into 1,000 tiny, manageable steps, a quiet, flowing river of production that made manufacturing faster and more efficient than ever before. Fact 65. The hot air balloon was lifted by a captured cloud. In 1783, the Montgolfier brothers discovered a simple and profound secret of the sky. Warm air is lighter than the air around it. They built a huge, delicate balloon from silk and paper and lit a fire beneath its opening. The balloon did not roar into the sky. It swelled, filled with a great, invisible cloud of heated air, and then, with a silent, graceful power, it began to rise. This was humanity's first flight, not with a powerful engine, but with the gentle, persistent lift of warmth itself, a quiet ascent in a floating paper sphere. Fact 66. The Geiger counter gave a voice to the invisible. The world of atomic radiation is a silent one, an unseen energy that can be both useful and dangerous. The Geiger counter, invented in the early 20th century, gave us a way to hear this silent world. Its core is a simple tube filled with gas. When a single particle of radiation passes through this tube, it knocks an electron loose, creating a tiny cascade of electricity. This small, silent event is then amplified into an audible click. Each quiet pop is the sound of a single atom decaying, a simple, reliable voice that allows us to measure the invisible presence all around us. Fact 67. The screw is a mountain path wrapped around a pole. The simple screw is one of the most powerful and ancient inventions. It is, in essence, an inclined plane, a gentle ramp, that has been wrapped around a central cylinder. This quiet and ingenious design translates a gentle turning motion into a powerful, direct force. When used as a fastener, each turn pulls it deeper, holding materials together with an immense and lasting grip. When used as in the Archimedes screw, this same gentle turning can coax water to walk quietly uphill, a simple, rotating path that can lift a river. Fact 68. The Bessemer process turned iron into steel with a single breath. For centuries, making steel was a slow, expensive, and difficult art. Iron, which is brittle, had to be painstakingly purified. In the 1850s, Henry Bessemer discovered a shockingly simple solution. He realized that the impurities in molten iron were mostly carbon. By simply blowing a blast of hot air through the liquid iron, the oxygen in the air would bond with the carbon and burn it away in a fiery but rapid process. This single, quiet insight, that the solution was to add a breath of air, made it possible to produce strong, versatile steel quickly and cheaply, providing the silent, strong skeleton for the modern world. Fact 69. The Haber-Bosch process learned how to pull food from the air. The air all around us is nearly 80% nitrogen, an essential nutrient for all plant life. But plants cannot use this nitrogen directly. For all of history, agriculture was limited by the amount of usable nitrogen in the soil. In the early 20th century, the Haber-Bosch process changed this forever. It is a chemical reaction that uses high pressure and temperature to mimic the way lightning breaks apart nitrogen molecules, allowing them to be combined with hydrogen to create synthetic ammonia fertilizer. It was a quiet, industrial-scale miracle that gave humanity the ability to pull the building blocks of life directly from the air, averting a global food crisis. Fact 70. Fiber optics is a tube that traps a beam of light. A beam of light naturally travels in a perfectly straight line. The magic of a fiber optic cable is that it persuades light to turn corners. Each cable is a hair-thin, perfectly pure strand of glass. As a pulse of laser light travels down this strand, it constantly strikes the inner wall of the glass at a very shallow angle. This causes a phenomenon called total internal reflection, where the wall acts like a perfect, flawless mirror. The light is silently and perfectly bounced back and forth, millions of times, as it travels for miles, losing almost none of its intensity. It is this quiet, internal echo that allows us to send messages as pulses of light across the bottom of the ocean. Fact 71. The combine harvester performs a quiet ballet in the field. The harvest was once a series of separate, strenuous tasks, reaping the stalks, threshing them to loosen the grains, and winnowing to separate the grain from the chaff. The combine harvester, as its name suggests, combined all these steps into one continuous, flowing process. As the large machine moves slowly through a field, it quietly cuts the crop, pulls it inside, separates the valuable grain, and gently casts the leftover straw back onto the field. It is a single, efficient, and peaceful dance that allows a small number of people to gather the bounty of a vast landscape. Fact 72. The water wheel borrowed a river's gentle strength. For thousands of years, the water wheel was one of humanity's most important engines. It was a quiet and perfect partnership with nature. By simply placing a large wheel in the path of a gently flowing river or stream, the steady weight and movement of the water would cause the wheel to turn in a slow, rhythmic, and tireless rotation. This quiet power, transferred through simple gears and shafts, could grind grain into flour, saw logs into lumber, or power a blacksmith's bellows, all without consuming a single piece of fuel, simply by borrowing the river's constant, peaceful journey to the sea. Fact 73. Sonar learned how to see with a whisper of sound. The deep ocean is a world of total darkness, a place where light cannot reach. To map this hidden world, we developed sonar. The process is one of quiet patience. A device sends out a short, focused pulse of sound, a ping, into the depths. This sound travels down through the water until it strikes an object, like the ocean floor or a submarine, and then a faint echo bounces back. By listening for this echo and measuring the precise amount of time it took to return, we can calculate the distance to the object, slowly building a detailed picture of the silent, unseen landscape below. Fact 74. The ball bearing replaced the struggle of sliding with the grace of rolling. Whenever two surfaces slide against each other, they create friction, a force of resistance that wastes energy and causes wear. The ball bearing is an invention of profound, quiet elegance that defeats this struggle. It places a ring of small, perfectly smooth, and hardened steel balls between a stationary part and a moving part. Instead of grinding against each other, the two surfaces now glide effortlessly on top of these tiny, rolling spheres. This simple, hidden invention is what allows the wheels of a skateboard and the motors in a fan to spin with a silent, frictionless grace. Fact 75. The pacemaker is a quiet conductor for the heart. The heart is a marvel of natural rhythm, but sometimes this rhythm can falter. The medical pacemaker is a tiny, silent guardian that restores this essential beat. Implanted just under the skin, this small device constantly and quietly listens to the heart's own electrical signals. If it detects that the rhythm has become too slow or has paused, it sends a tiny, precise, and painless electrical pulse to the heart muscle, gently reminding it to beat. It is a quiet, internal metronome that maintains the steady, life-sustaining tempo of our inner world. Fact 76. The suspension bridge is a road that hangs from the sky. To cross a wide expanse of water, building pillars from below is often impossible. The suspension bridge offers an elegant, beautiful solution. Instead of being pushed up from below, the roadway is hung from above. Two massive, primary cables, made of thousands of strands of steel wire, are draped in a graceful, natural curve between two tall towers. From these main cables, hundreds of smaller vertical cables reach down, like strong, silent threads, to hold up the bridge deck. It is a quiet masterpiece of tension, a way to use the strength of a simple curve to let a road float, almost weightlessly, across the water. Fact 77. The QR code is a silent doorway made of pixels. The simple barcode could only hold a small amount of information in its vertical lines. The QR, or quick response, code expanded this idea into 2 dimensions. Its complex pattern of black and white squares on a grid is a quiet, static language that can store thousands of characters of information. When you point your phone's camera at it, the device instantly reads this silent pattern, translating it into a website address, a piece of text, or a Wi-Fi password. It is a simple, unassuming key that can, with a single quiet glance, open a doorway from the physical world directly into a specific corner of the vast digital universe. Fact 78. The mortar and pestle is a conversation between 2 stones. One of humanity's oldest and most essential tools, the mortar and pestle is a testament to the power of gentle, repetitive work. It is a simple partnership, a heavy, bowl-shaped stone and a smaller, rounded grinding stone. Through a quiet, rhythmic process of pressing and turning, this simple tool transforms hard, inedible grains into soft, digestible flour, or tough herbs into fine, aromatic powders. It was one of our very first machines, a quiet engine of transformation that was the foundation of cooking and medicine. Fact 79. Clockwork created a patient, mechanical memory. The true magic of a clockwork device is not just its movement, but its ability to store and release that movement over a long period. By winding a spring or lifting a weight, energy is quietly stored. A carefully designed train of interlocking gears and levers then allows this energy to escape in a slow, predictable, and controlled manner. This is the quiet, intricate heart of everything from a simple music box, which patiently remembers a melody, to the complex astronomical clocks that charted the silent movements of the heavens. It was the first way we taught a machine how to perform a long and complex task all on its own. Fact 80. The microscope revealed a universe in a drop of water. While the telescope opened up the vastness of the cosmos, its quiet twin, the microscope, revealed an equally vast and teeming universe hidden right under our noses. By using a clever arrangement of finely ground lenses, this simple instrument magnified the unseen world. In a single drop of pond water, Anthony van Leeuwenhoek, a Dutch shopkeeper, discovered a silent, swirling world of tiny animalcules. This quiet revelation that we are surrounded by a world of invisible life was the dawn of microbiology, forever changing our understanding of disease, biology, and life itself. Fact 81. The windmill learned to harvest the breath of the sky. In places where rivers were scarce, humanity found another source of quiet, tireless power: the wind. The windmill is a graceful and elegant machine, its large sails angled to catch the invisible currents of the air. It does not fight the wind, but rather collaborates with it, turning its gentle, horizontal push into a strong, rhythmic rotation. This quiet, steady motion, transferred through a simple wooden shaft, could turn a heavy millstone to grind grain or pump water from deep within the earth. It was a beautiful, silent engine powered by the tireless breath of the planet. Fact 82. The cat's eye reflector is a small, perfect echo of light. On a dark and foggy night, an inventor named Percy Shaw was driving when he saw the faint reflection of his car's headlights in the eyes of a cat sitting by the road. This gave him a simple, brilliant idea. The cat's eye road marker is a small, passive gem of engineering. It contains a small glass sphere that, when light enters it, focuses that light perfectly onto a small, curved mirror at its back. This mirror then bounces the light directly back along the same path it came from. It is a silent, clever guide that requires no power of its own, simply borrowing the light of a car to create a bright, quiet path in the darkness. Fact 83. Kevlar is a fabric that has been taught to be a net. We often think of stopping a projectile with something hard, like a wall of steel. The genius of Kevlar is that it is soft. It is a synthetic fiber that, when woven into a dense fabric, has an incredibly high tensile strength. When a fast-moving object strikes it, the Kevlar vest does not shatter it. Instead, it quietly catches it, like a net. The many layers of strong, tightly woven fibers instantly share the force of the impact, absorbing and dissipating the immense energy across the entire panel. It is a silent, flexible shield that finds its strength not in rigidity, but in yielding. Fact 84. The codex turned the scroll into a quiet conversation. For centuries, long texts were written on scrolls, which were cumbersome to read and almost impossible to reference quickly. You had to unroll the entire thing to find a passage near the end. The invention of the codex, which is the form of the modern book, was a simple but profound change. By cutting the long scroll into individual pages, stacking them, and then quietly sewing them together along one edge, a new kind of object was born. The codex allowed for random access, the ability to open it to any page at any time. This quiet innovation made knowledge more intimate, portable, and easier to navigate, a perfect design for thought that has remained with us for nearly 2 millennia. Fact 85. The first television painted a ghost with light. Before the electronic television we know, the first successful images were transmitted mechanically. In the 1920s, inventors like John Logie Baird used a simple spinning disc with a spiral of holes cut into it. As this disc spun, each hole would rapidly scan one line of a scene, letting a small piece of light fall onto a sensor. This quiet, mechanical process translated a physical scene into a fluctuating electrical signal. At the other end, a receiver with a synchronized spinning disc would rebuild the scene, line by line, as a small, flickering, ghostly orange image. It was the quiet, humble beginning of seeing at a distance. Fact 86. The credit card is a silent promise made of plastic. For most of history, a purchase was a physical act, an exchange of tangible coins, notes, or checks. The first credit cards, introduced in the 1950s, replaced this with something far more abstract: a promise. This simple plastic card, with a signed name on the back, was a quiet symbol of trust between a customer, a merchant, and a bank. The transaction itself became a silent, simple act, an imprint of numbers, a signature, that untethered purchasing from the physical money in one's pocket, a quiet revolution in the nature of exchange. Fact 87. The perfection of the printing press was a quiet symphony of ideas. Johannes Gutenberg's genius was not in inventing a single thing, but in quietly combining several existing technologies into one perfect system. He took the screw press, used for centuries to make wine and paper, and adapted it to create a sharp, even impression. He used his knowledge of metallurgy to create a durable metal alloy that could be cast into precise, individual, and reusable letters. And he developed a new kind of oil-based ink that was thick enough to stick to the metal type. It was the quiet, patient harmony of these separate innovations that created a machine capable of changing the world. Fact 88. The airbag is a soft cloud that blooms in an instant. The airbag is a marvel of quiet, instantaneous chemistry. It waits patiently, hidden in a steering wheel or a dashboard, for years. But in the fraction of a second that a collision is detected, a sensor sends a tiny electrical spark to a chemical igniter. This triggers a rapid, but not explosive, chemical reaction that produces a large volume of harmless nitrogen gas. This gas inflates a folded nylon bag into a soft, protective cushion, a quiet cloud that emerges just in time to gently slow a person's momentum and cushion them from the hard surfaces of the car. It is a silent guardian that does its work in the blink of an eye. Fact 89. The seed drill gave each seed a proper home. For thousands of years, farming began with an act of hope, scattering seeds by hand across a plowed field. It was a wasteful process, as many seeds were eaten by birds or failed to sprout. In the 18th century, Jethro Tull's seed drill brought a new, quiet precision to this act. It was a horse-drawn machine that would first open a small, straight furrow in the soil, then drop individual seeds down a chute at a regular interval and a consistent depth, and finally, a small rake at the back would cover the seeds with earth. This simple, gentle act of tucking each seed into the soil was a quiet revolution that dramatically increased crop yields and helped feed a growing world. Fact 90. The escalator is a river of stairs. The elevator is a room that moves, but the escalator is something more fluid. It is the path itself that is in motion. It is a quiet, continuous, and endlessly looping staircase, a gentle mechanical river designed to carry people effortlessly from one level to another. The steps themselves are part of a hidden chain that is constantly moving in a slow, steady cycle. As the steps reach the top or bottom, they quietly disappear into a landing plate, travel underneath, and then re-emerge to begin the journey again. It is a simple, silent, and graceful solution to the simple problem of going up or down. Fact 91. The Polaroid camera was a quiet, personal darkroom. For its first century, photography was a two-part process: taking the picture, and then, much later, the complex chemical art of developing it in a darkroom. Edwin Land's invention of the instant camera in 1948 was a quiet miracle that placed this entire darkroom inside the camera itself. Each piece of film was a self-contained package, complete with tiny, sealed pods of developer and fixer chemicals. After the picture was taken, a set of rollers would pull the film out, bursting these pods and spreading the chemicals evenly to begin the development process. The quiet were of the camera, and the slow, magical appearance of a full-color image from a blank square was a new kind of wonder, a memory you could hold in your hand, just moments after it was made. Fact 92. The pencil is a tool for erasable thoughts. The core of a modern pencil is not lead, but a soft, harmless mineral called graphite. First discovered in a massive, pure deposit in England, shepherds used chunks of it to mark their sheep. The genius of the pencil was to encase this soft, grey material in a sleeve of wood, making it clean and easy to hold. It leaves a quiet, temporary mark, a whisper of a thought that can be easily erased and rethought. It is the perfect tool not for final statements, but for the gentle, quiet, and forgiving process of creation. Fact 93. The lead is a crystal that learned how to glow. For a century, our electric light came from a hot, fragile, and inefficient filament burning inside a glass bulb. The light-emitting diode, or LED, is a completely different kind of light. It is a tiny, solid crystal, a semiconductor, that has been designed to emit a photon of light when a small, cool electric current passes through it. There is no burning, no filament, and almost no wasted heat. It is a quiet, pure, and incredibly efficient conversion of electricity directly into light, a tiny, enduring jewel that now illuminates our world. Fact 94. Vulcanized rubber was a quiet kitchen accident. Natural rubber was a fascinating but frustrating substance. It would melt in the heat and become brittle and crack in the cold. In 1839, after years of searching for a way to make it stable, a struggling inventor named Charles Goodyear accidentally dropped a mixture of rubber and sulfur onto a hot stove. Instead of melting, the mixture charred like leather but remained flexible and strong. This quiet kitchen accident was the discovery of vulcanization, a process that cross-links the rubber's polymers, creating a stable, waterproof, and elastic material that gave us everything from durable tires to the quiet soles of our shoes. Fact 95. Stainless steel is iron that was taught how to heal itself. Iron's great weakness is its tendency to rust, to slowly and quietly surrender to the air. In the early 20th century, It was discovered that adding a small amount of the element chromium to molten steel gave it a remarkable new property. The chromium reacts with the air to form a microscopically thin, transparent, and incredibly tough protective layer on the steel surface. This passive layer quietly shields the iron from rust, and if it is ever scratched, this invisible shield instantly and silently heals itself. It was a simple addition that gave us a strong, beautiful, and enduring material. Fact 96. The Soothe system is a silent, hidden river of health. The greatest cities of the past were often plagued by disease, a direct result of the accumulation of waste. The invention of the modern Soothe system was a quiet, invisible, and profound revolution in public health. It is a vast, hidden network of precisely sloped pipes, a man-made river that uses the gentle, persistent pull of gravity to silently carry waste away from homes and streets. This quiet, unseen infrastructure has done more to prevent the spread of disease and allow for the growth of healthy, dense cities than almost any other single invention. Fact 97. Bubble wrap was invented as a failed wallpaper. In 1957, two engineers were trying to create a new kind of textured, three-dimensional plastic wallpaper. They sealed two sheets of plastic together in a way that trapped a grid of air bubbles between them. As a wallpaper, it was a complete failure. But they soon realized their invention had another, quieter purpose. It was a wonderfully lightweight, transparent, and effective cushioning material. Each trapped bubble was a tiny, silent pillow of air, a perfect, gentle protector for fragile objects. It was a quiet failure that found its true calling as a guardian. Fact 98. The shipping container created a single, global language for cargo. Before the 1950s, loading a ship was a slow, chaotic, and expensive process of handling individual crates, barrels, and sacks. A former trucking magnate named Malcolm McLean had a simple, quiet idea. What if all cargo could be placed into identical, secure, and stackable metal boxes? This was the birth of the modern shipping container. This simple, standardized box created a universal language for logistics. A container could be filled in a factory, sealed, and then moved seamlessly by truck, train, and ship without ever being opened. This quiet innovation drastically reduced the cost and time of global trade, silently weaving our modern world together. Fact 99. The water clock was time measured in a quiet drop. Long before the ticking of gears, humanity measured the hours with a slow, steady, and silent flow of water. The clepsydra, or water clock, was a simple and beautiful device. A large vessel would be filled with water, which was allowed to escape, drop by steady drop, from a tiny spout near the bottom. As the water level inside the vessel silently fell, a series of marks on the inner wall would indicate the passing of the hours. It was a fluid and peaceful way to track time, a quiet, gentle rhythm that governed the temples of ancient Egypt and the law courts of ancient Greece. Fact 100. The number 0 was the invention of nothing. Perhaps the most powerful invention in all of history is not a physical object, but a quiet and profound idea, the number 0. For millennia, mathematics had no way to represent the concept of nothing, or to act as a placeholder in a number like 101. The concept of 0 as a number in its own right, which emerged in India around the 5th century AD, was a silent revolution. This simple symbol for emptiness unlocked the power of the decimal system, making complex arithmetic and algebra possible. It was the quiet, humble, and paradoxical invention of nothing that gave us everything in the world of numbers.